We want to sketch each angle in standard position and then convert the angle in degrees to radians. When an angle is in standard position, the initial side is along the positive x-axis. When the angle is positive, the rotation is counterclockwise. When the angle is negative, the rotation is clockwise. I've listed several common angles in degrees below for reference. 360 degrees equals one full rotation counterclockwise from the positive x-axis. 180 degrees is half a rotation counterclockwise from the positive x-axis. 90 degrees is 1/4 of rotation counterclockwise from the positive x-axis, and so on. You may want to pause the video and review these common angles because we should be familiar with all of them. The first angle is 82 degrees. We start with the initial side along the positive x-axis, and then because the angle is positive 82 degrees, which is 8 degrees less than 90 degrees, we rotate a little bit less than 1/4 of rotation counterclockwise. We indicate the rotation using an arrow like this. And we'll stop just short of 1/4 of rotation counterclockwise and then sketch the terminal side, which would be this right here. And now let's convert the angle to radians. Because 180 degrees is equal to pi radians, to convert from degrees to radians, we multiply the angle in degrees by pi divided by 180 degrees. Let's first write 82 degrees as a fraction with the denominator of 1, and then multiply by pi divided by 180 degrees. The units of degrees simplify out, and then 82 and 180 share a common factor of 2. There are 41 2's in 82 and 92's in 180. 82 degrees is equal to 41 pi divided by 90 radians. Next we have 145 degrees. The initial side is along the positive x-axis. We now rotate 145 degrees counterclockwise, which is less than half a rotation counterclockwise because 145 degrees is less than 180 degrees. And because 45 degrees times 3 is 135 degrees, we'll rotate a little bit more than 3/8 of a rotation counterclockwise. So if we had 1/8, 2/8, 3/8 for rotation counterclockwise, this would be 135 degrees, and therefore we rotate 10 degrees more to, let's say, approximately here. This would be the terminal side for 145 degrees. And now let's convert 145 degrees to radians. Write 145 degrees as a fraction with the denominator of 1, multiplied by pi divided by 180 degrees. The degrees simplify out. The greatest common factor of 145 and 180 is 5. There are 36 5's in 180 and 29 5's in 145. 145 degrees is equal to 29 pi divided by 36 radians. I should mention sometimes you will see an RAD for radians after the angle, but it's also common to assume if no units are given, the angle is in radians. Next we have 230 degrees. The initial side is along the positive x-axis. And now we rotate counterclockwise 230 degrees. Half a rotation is 180 degrees. We need to rotate 50 degrees more, and since 45 degrees is 1/8 of a rotation, we rotate a little more than another 1/8 of a rotation to approximately here. This would be the terminal side for the angle measuring 230 degrees. And now let's convert to radians. The greatest common factor of 230 and 180 is 10. There are 23 10's in 230, 18 10's in 180. And again, the degrees simplify out, and we're left with radians. We have 23 pi divided by 18 radians. And for the last example, we have 324 degrees. Initial side is along the positive x-axis. 3/4 of a rotation counterclockwise would be 270 degrees. We need to rotate 54 degrees more to approximately here. And now let's convert to radians. This one's a little more challenging. The greatest common factor between 180 and 324 is 36. There are 536 in 180 and 936s in 324. 324 degrees is equal to 9 pi divided by 5 radians. I hope you found this helpful.